All right, let's talk about something big, a new AI architecture called Mamba. And listen, this isn't just another small update. We're talking about a technology that could potentially dethrone the king, the architecture that powers, well, pretty much all of the AI you use today.
Whether you're chatting with ChatGPT or creating incredible art with Midjourney, you're interacting with the same fundamental technology. There's this one architecture that just rules everything.
And that, of course, is the transformer. It's been the absolute undisputed champion for years now. It's the engine behind this entire AI revolution we're living through.
But here's the kicker. What if this amazing, world-changing technology has a secret, a fatal flaw? Something that's actually been holding AI back this whole time.
So let's get into it. This problem has a name, and it sounds pretty dramatic: the Transformers Quadratic Curse.
Okay, so what on earth does that actually mean? Well, imagine you're reading a book, but for every single new word you read, you have to go all the way back to the very first page and reread everything up to that point. Sounds insane, right? Incredibly inefficient. But that's pretty much how a transformer works. As you feed it more information, a longer sentence, a bigger document, the amount of work it has to do, the memory it needs, doesn't just go up a little bit. It squares. It grows exponentially. And this makes trying to process really, really long things, like an entire book or a strand of DNA, just unbelievably expensive and slow. And this is exactly where our new contender storms onto the scene. Say hello to Mamba. It's an architecture designed from the ground up to fix this exact problem.
Okay, just look at this comparison. The differences are, well, they're stark. While the Transformer is stuck with that inefficient quadratic scaling, Mamba is linear. That is a huge deal for efficiency. And what does that mean in practice? It means inference, so generating answers, can be up to 5 times faster. Think about that. And when it comes to long contexts where transformers just choke, Mamba thrives. We're talking sequences up to 1,000,000 tokens long. But here's the most important part. It's not trading quality for speed. Mamba is doing all of this while matching or in some cases even beating state-of-the-art transformers.
So, the big question is, how in the world does Mamba do this? What's its secret sauce? Well, it all comes down to one brilliant core idea: selective memory.
So remember our crazy book analogy? Instead of rereading everything from page 1, Mamba is more like a genius speed reader who takes incredibly smart notes. It scans the input one piece at a time, token by token. Then, and this is the key, it decides what's actually important and updates this tiny compressed memory of its own, its state. And just as crucial is what it doesn't do. It actively forgets the junk, the fluff, the irrelevant info. This keeps its memory lean, focused, and super efficient. And you don't have to take my word for it. The researchers who created it said it best. They said Mamba can selectively propagate or forget information depending on the current token. That right there is the magic. It's content aware. It's not just blindly processing data. It's making smart choices about what to remember and what to let go of. All right, so the theory sounds incredible, but we all know that's just half the story. Does it actually work in the real world? Let's put Mamba to the test and look at the hard data. First up, we're throwing Mamba right into the lion's den, the Transformers' home turf, language modeling. So what we're looking at here is perplexity, which is just a fancy way of saying how good a model is at predicting the next word. Lower is better. And would you look at that? Mamba is right there, neck and neck with a super optimized Transformer++. Let me be clear, this is a really big deal. This is the first time a model that scales linearly has actually hit the same quality as the top-tier transformers on their own game. And it doesn't just stop at quality, it's about speed. When you actually ask it to do something, to generate a response, Mamba is cranking out text at 5 times the speed. Let that sink in. The same top-tier quality, but 5 times faster. Okay, but can it reason? This table pits Mamba against Pythia, a really well-known transformer of the same size, on common sense tasks. And look at the scores. Mamba doesn't just keep up, it blows past it. So again, we're not making a trade-off here. We're not sacrificing smarts for speed. We're getting both. All right, now let's move away from the transformer's comfort zone. Let's see what happens when we go to the places where it really falls apart. Domains with crazy long sequences, like DNA and audio. This chart is just fascinating. We're modeling the human genome here. Now watch what happens as the sequence gets longer and longer. The other models, their performance tanks. They're basically getting lost in the noise. But Mamba's performance actually improves. Its selective memory is a superpower here, allowing it to ignore all the irrelevant bits and focus only on the signals that matter, even across these huge, massive sequences. And the story is just as wild when you look at audio. The metric here is FID score, and again, lower is way, way better. The previous best model in the world, Sashimi, scored a 1.99. Mamba comes in at 0.67. That's not an improvement. That's a demolition. It's a completely different league. It just set a new state of the art by a mile.
Okay, so after seeing all of that, you have to ask the question, right? Is this it? Are we looking at the new backbone for all of AI?
I mean, let's just run through the checklist. It's got transformer-level quality. Check. It has linear scaling so it can handle ridiculously long sequences. Check. It's up to 5 times faster for inference. Check. And it's a generalist that crushes it on text, audio, and genomics. The case for it being the next big thing, it's pretty darn compelling.
So let's end on this thought. We are standing on the edge of a new era. An era where AI can process an entire human genome with the same ease it processes a simple sentence. Just think about that. What becomes possible when you have that kind of power? What problems that we think of as impossible today will we be solving tomorrow?